Welcome to this video. We're going to learn how a coal-fired power plant works. Now, it doesn't have to be coal that we use. It could be natural gas or other things. Here's the basic process. Over here you have a furnace. The furnace burns whatever fuel you're using. So if you're using coal, you load up the coal over here in the furnace, you set it on fire, and what happens? It explodes, it combusts. And when it combusts, it releases these fumes which are at a tremendously high temperature. Those fumes carry a lot of heat. So what happens to the fumes? They heat up water in these pipes. Let's watch. So there's water moving through these pipes, getting hotter and hotter. As the water heats, it rises because its density decreases, and eventually it goes all the way up here to this thing which is a boiler. Now, it's hot down here, right? It's hot down here. It's hot up here. It's hot everywhere. So the boiler is just another stage of heating the water. So the water heats up in these pipes, goes to the boiler, and then it becomes steam. And the boiler is designed to make that steam at a really high pressure. So it's a very, very fast-moving steam, a high-pressure steam. It shoots out of this inlet, and it flies into this turbine right here, called a steam turbine. Now the turbine looks something like this. So here's our turbine over here, right? This is the turbine that's used in some coal-fired power plants. All these little blades there, you can imagine them looking something like this. So what happens? The steam flows in really fast against these blades, right? Really high speeds. What do? What's that steam do? It turns the blades around. This thing rotates. And when it does, it rotates this shaft here. And that shaft is connected. What's it connected to? The turbine shaft is connected to this thing called a generator. Now, we don't know what's in a generator. Well, it's a magnet. I'll tell you, it's a magnet. But we don't have to learn about generators. We don't have to learn about how they work, even though it's through something called electromagnetic induction. The point is, when you spin the magnets in the generator, they produce electricity. Okay? So by turning these things, we're generating electricity. The whole point here is to create steam, send it through really fast, do some turning, make your electricity, and repeat the cycle. But to repeat this cycle, we need water once more. Why do we need water? Well, because the only reason you get motion through the pipes, the only reason there's motion, is because the water rises as it becomes steam. So you need water turning to steam to get that rising motion, which is part of what drives the cycle. Another way to think about it is with pressure. When the pressure is really high here, and the pressure is really low down here, you are going to get air forced through those turbine blades and across the blades. So to get that forcing through, you need a pressure difference, high pressure going to low pressure. And how do we produce the lower pressure? We cool that steam and we make it water again. So how do we get that water to cool down? How do we get the steam to cool and become water? It's a tremendous temperature we're dealing with, and you have to get rid of a lot of heat to make it water once more. Well, what we do is we use a cooling loop. But before we talk about the cooling loop, let's just watch the steam loop, the steam cycle. The water comes up, it turns into steam, it's forced through the turbine across the blades, and it spins those blades. It cools down over here by some mysterious process. It becomes water, and it repeats. So it's the same water and steam that we use the entire time. Okay, how do we get the cooling effect? What we do is use a second loop or cycle. Over here there's a lake or an ocean or a man-made reservoir, something else that's got some pretty cool water. This water stays at a roughly constant temperature. We feed in water through a pipe from that, we pump it in from the reservoir through a pipe, and we pump it toward this steam chamber. Now this is called a condenser. So what we do is we exchange the heat from the steam, which is hot, to the cold reservoir water, and by doing that, we bring that hot water. By the time the water in the pipe gets down to this bottom pipe, it has exchanged a lot, it's gained a lot of heat from the steam. So the water is hot, and the steam is cold. So the steam condenses back into water here, down here, and that water continues through the steam loop while this hot pipe water returns back to the reservoir. What happens when the hot water gets back into the reservoir? It cools down again, and this cycle, this cooling loop, continues. So let's watch that in the animation. The arrows show where the water is going. Cold water comes in, it heats up because of the steam, and it exits back into the reservoir, where it cools off once more. There's one final note. This pipe system here is called a heat exchanger. Why? We're exchanging heat from one thing to another thing. So what's heat being exchanged between? Heat starts out, the energy starts out with these fumes from the coal, the combustion fumes, and those combustion fumes exchange their heat through the pipes, through the heat exchanger, to the water. This is a heat exchanger too, down in the condenser, but we don't typically refer to it like that. Instead, when we talk about in these IB problems, when we talk about heat exchanger, we're referring to this one inside of the boiler, or as part of the boiler system. Okay, so back to our notes. Fossil fuels are what we use in this type of setup. We've got a big boiler right here, a furnace. We've got basically one way we could draw this, and this is another way to draw it. You can make your furnace down here, and you've got this coal. It releases these hot combustion fumes, these combustion gases, which rise. And what do? They heat that water, they turn that water into steam. Here's the steam. And then that fast-moving, high-pressure steam comes rushing out toward the low-pressure point. Here's the low pressure. So it rushes out, runs across these blades, turns the steam turbine, and then comes back down, where it condenses and becomes water again. Now, the condensing, the water process, right, condensing back to water, is by virtue of a system that we haven't, a loop we have not shown. There's another cycle over here, you don't need to draw it, but it feeds water back into a lake, right? So here's a reservoir or a lake or something over here. The way that I've drawn it, this is where the lake water is. The lake water goes in, it heats up, and then it comes back out, where it cools off and becomes regular temperature lake water again. So what I want you to do is explain, fossil fuels. By the way, here are what fossil fuels are. Read over this definition. You're a plant, you die, you decay, you become buried over lots of time. You become buried maybe below the ocean floor or somewhere else, and then thousands of years convert you into crude oil. So that's one of the ways that fossil fuels are generated. It doesn't have to be crude oil. It could be coal. Natural gas comes about from this process. So for your three fossil fuels, here they are: coal, natural gas, and oil. You've probably heard of those. Write those down and then take a moment to do this. Explain the process, right? Explain the process. And I'm not going to give you an answer. Do it in your own words.